concept of crisis for me is the idea that when you apply a small perturbation, you might, for instance, insert just a single infected individuals in a population. If you are in a certain range of parameters, you can create macroscopic effects. So basically, to small perturbation, to small changes of the system, you get microscopic and dramatic changes to the entire system. And that's a typical example of crisis. In epidemiology, for instance, this is related to the concept of epidemic threshold and the fact that if the disease has enough spreading velocity, it can pervade the entire system, even if you just insert a few infected individuals. For me, it's really emergency is related to how from microscopic interactions we can get macroscopic long-range ordering of a systems that you cannot easily predict from the interaction among single individuals or from the properties or attributes of the single unit in the system. Examples goes from the typical and very classical example of ants colony, in which ants have are able to develop large and sophisticated forms of collective behavior just by simple signals among the individual ants. Two other examples that are like the internet as a global system. We know that the internet doesn't have a blueprint or a master control or anyone that really can be planning for the internet as a whole. However, we have at the end of the day a system that basically works day by day, that involves millions of users, and that's for sure the outcome of an emergent phenomenon in which many interacting agents are able at the end to create a collective ordering for the system that merge technical and market and social behavior in something that works in every business day. Well, dynamics is basically the core of the problem, because we have been saying that there is no blueprint or mastermind in complex systems, but somehow the blueprint of the systems, of their behavior, also of the microscopic behavior, is embedded in the dynamics of the individual units. And so the dynamics is at the core of the problem. At the same time, what is most interesting is the dynamical patterns that the systems acquire on the large scale when you have cooperative and macroscopic behavior. Well, disorder and heterogeneity is the richness of the system, is what allow us to have things which are not flat, which are not boring. A tank full of gas would be somehow a complex system, but it's not like that just because, the individual molecules are all the same. What we look into complex system is diversity, is the fact that we have agents with different behaviors, and this create a richness of dynamical processes and cooperative phenomena that is what is the interesting part of complex systems. There are two kinds of disorder. Disorder may be the disorder in the sense of the heterogeneity of the single units, or it can be the disorder in the sense that, for instance, a large network like the internet could appear as an haphazard set of points. I think, that the disorder on the large scale is what we try to simplify with complexity theory. So what we want to understand, what we want to do is to rationalize this disorder and make it an order in a sense. So what we want to do is to simplify the system, to find understanding usually corresponds to simplification, and this is what we are trying to do in complex systems.